Hi everyone, my name is Abraham Aslamides, and today I'll be talking about rhubarb, a crop that might seem familiar in the kitchen, but actually has a fascinating history and surprising scientific relevance. Rhubarb is part of the buckwheat family and botanically classified as an herbaceous perennial, which means it has a fleshy root system that survives underground over multiple years. Unlike many crops, it's not replanted annually. Instead, it sends up new stalks and leaves each spring from its crown. This makes it especially valuable in temperate climates where it can be a reliable source of early season produce. It's cultivated across temperate regions around the world, particularly in places with cool winters, because it has a chilling requirement where it needs 7 to 9 weeks of cold temperatures below 3 degrees Celsius to break its dormancy and resume growth in the spring. Only the stalks, called petioles, are edible. They're known for their sour flavor and are commonly used in pies and preserves. The leaves, however, are toxic due to high oxalate concentrations and should never be consumed. Another interesting note is how rhubarb is classified. Although it's a vegetable by culinary standards and botanically it is not classified as a fruit, US tariff law has classified rhubarb as a fruit since 1947. So this legal definition was based on trade policy and lower import duties for fruits at the time. So rhubarb has this unique identity that straddles culinary, botanical, and these legal trade classifications. On the top right here, we can see the crown bud break and early leaf expansion of rhubarb, and on the bottom right, the flower stalks of the rhubarb plant. Rhubarb's history stretches back over 5,000 years. It was one of the first medicinal plants traded along ancient Eurasian routes. The roots of the plant, not the stalks, were the original commodity and were highly prized in Chinese and Islamic medicine. In these traditions, rhubarb was used for its laxative properties, and it continues to be recognized in Chinese pharmacopoeias today. Culinary use of the stalks is relatively recent, beginning in 18th century England. This change coincided with the wider availability of sugar, which helps temper the plant's natural acidity and make it suitable for desserts and preserves. One of the most innovative developments in rhubarb cultivation came in 1815 with the British practice of forcing, which is shown here on the left. This method involves growing rhubarb in complete darkness, traditionally in heated sheds lit by candles. Without sunlight, the plant can't produce chlorophyll, so the energy stays concentrated in the stalks, making them tender and sweet. You can see here on the left, the leaves are very small and pale, and that's because they can't produce the chlorophyll. This process also allows for harvesting in winter and early in the spring, well before other local fruits are available. Today, this heritage is celebrated in cultural festivals like Wakefield's Rhubarb Festival in Yorkshire, England, and Rhubarb Days in Sumner, Washington. These events reflect how rhubarb's identity has shifted from a medicinal root to a beloved seasonal food and cultural symbol. There is wide cultivar variation in rhubarb. Some varieties are selected for vibrant red stalks, others for productivity or flavor. Uh, Names like Victoria and Cherry Red, Crimson Red are commonly grown. However, recent genetic studies show that naming conventions are not always reliable. For example, the strawberry variety and the Sutton variety have been found to be genetically identical, while a single name like Victoria may apply to genetically distinct plants. This creates confusion in commercial and amateur cultivation. Rhubarb's growth is also closely tied to seasonal conditions. As mentioned before, it has that chilling requirement to break its dormancy. Without the chilling period, crowns don't develop properly and yields are reduced. Soil fertility, especially nitrogen availability, also influences growth. Field trials in China's Qinghai Plateau showed that 150 kilograms of nitrogen per hectare yielded optimal biomass. Increasing nitrogen to 225 kilograms per hectare didn't improve yields further. In fact, when researchers looked at the production of anthraquinones, which are the plant's bioactive compounds, they found that nitrogen level had a smaller effect than seasonal variation. Between 2014 and 2017, anthraquinone concentrations varied more than twofold from year to year, regardless of fertilizer treatment. These findings show that rhubarb's productivity and medicinal value depend heavily on careful cultivar selection, cold exposure, and seasonal timing. And you can see some of the results of that study here in the data on the right-hand side. Rhubarb's tart stalks are popular in a wide variety of culinary preparations. These include pies, sauces, jams, chutneys, and increasingly fermented products like rhubarb wine, cider, and vinegar. Its natural acidity pairs well with sugar and aromatic spices, making it a versatile ingredient. Preserving rhubarb for year-round use is also common. Freezing helps retain color and texture. Drying and pressure canning are used for longer-term storage. However, due to its high acidity, rhubarb must be cooked and stored in non-reactive cookware like enamel-coated or stainless pans to avoid leaching metals and off flavors. On the commercial side, new markets are emerging. Cornell Agritech in New York, researchers are evaluating different rhubarb genotypes to identify ones best suited for beverage production. One challenge is that rhubarb's fibrous stalks are hard to juice using standard fruit presses, but after freezing and thawing, the tissue breaks down and releases more liquid, which opens up possibilities for small batch fermentation. In the UK, forest rhubarb grown in candlelit sheds has been making a comeback, driven by interest in seasonal artisanal produce. Growers use heritage techniques and regional branding to market their products to chefs and consumers worldwide. Altogether, these trends reflect how rhubarb's culinary appeal is being reimagined for modern markets. Rhubarb is not only a culinary crop, it also contains a wide range of bioactive compounds. Over 200 phytochemicals have been identified, especially in the roots. These include anthraquinones such as amodin, rheum, and alumodin, as well as flavonoids and stilbens. The compounds have shown promising pharmacological effects. For example, amodin and rheum influence signaling pathways, which are associated with inflammation, cancer progression, and liver function. In preclinical models, they've been shown to reduce tumor growth and induce apoptosis in cancer cells. However, not all compounds are equally safe, and the European Food Safety Authority has flagged alumodin and imodin as potentially genotoxic and possibly carcinogenic in food applications. Rheum, on the other hand, appears to have more favorable safety profile. Researchers are especially interested in the anti-liver cancer potential of these compounds. Meta-analysis show consistent evidence of tumor inhibition in both cell and animal models, but there's also evidence of dose-dependent toxicity, especially affecting liver and kidneys at high concentrations. So while rhubarb's medicinal potential is real, it must be balanced with caution. Ongoing research is essential to identify therapeutic applications that are both effective and safe. Here on the right, we can see chemical structures of 14 active pharmaceutical ingredients in rhubarb. To conclude, rhubarb is a remarkable plant that bridges botany, culture, cuisine, pharmacology. It's a hardy and adaptable plant. It's deeply seasonal, emerging when few other crops are available for harvest. From a cultural perspective, it has moved from ancient medicinal root to a springtime favorite celebrated in festivals. From a horticulture standpoint, it demands careful attention to cold exposure, fertilization, and genetic diversity. And in pharmacology, it offers real potential, especially in the realm of cancer research, though more work is needed to ensure its safety. Looking forward, the future of rhubarb depends on continued breeding programs to enhance traits like stalk color and flavor, as well as research into phytochemical safety. At the same time, its rising profile in local food movements and craft beverage industries shows that rhubarb still has a lot to offer in the 21st century. It's a perfect example of how ancient crops can continue to evolve and remain relevant, not just as food, but as medicine and as a symbol of regional identity and agricultural innovation. Lastly, these are the references used for this presentation. And thank you for your attention. I hope you've learned something about rhubarb today.